All right, guys, I want to go over really quick what a presentation would look like for your final exam. So hopefully, if you have watched the last video in the series called Model House Project, Final Upload, and Extra Credit, you will have seen the 10 different pictures and the 10 different components of the Model House Project that I really want you guys to emphasize. On my Model House Project here, I'm going to go over what a presentation would look like. So now that you've got those 10 pictures, you've uploaded them, you've completed this training model, you're going to use this to do your presentation. And your presentation would be something like this. I want you to start out with your name, go over all the different components of this thing, explain why those components are there, what their purpose is, and demonstrate your knowledge to me of this thing that you have created. So here's an example. Hello, my name is Daniel Bell. I'm going to demonstrate for you really quick the different components of wall framing and what we've got here in this particular little model. In this little model, we have a half-inch piece of CDX plywood that is the base of the model. The CDX plywood is the common material used for the walls of wall framing, or sometimes the plywood that goes on a roof. And we've got it here on this particular model because it is in perfect scale to a 4-inch concrete slab, which is commonly found here in Southern California where we are. On top of that model slab, we have our walls. The walls are consisting of a bottom and top plate, which hold together all of the other components. These components consist of vertical studs, which actually hold the majority of the vertical load of a house. We have corner posts, which consists of 3 pieces plus 1 from the other wall, which is 4 total, or 2 pieces plus 1 from the other wall, which is 3 total. These two different types of corner posts, both will give you an inside nailer so that the drywall has a place to nail on either side of the corner in a wall. But the advantage of the one with only 3 total is that there's an extra little cavity in the wall here. That cavity would allow insulation to be filled into the corner further, giving the house a better insulated envelope or an insulated wall. The beefed up corner here with more wood gives you less ability to put in insulation, meaning there's more gaps and thermal bridging between these pieces for cold air to get through without as much insulation in the wall. The openings, which is typically for a window like this or a doorway like this, comprise of very specific components and are similar. They're marked on the plates with a K for king studs and a J for jack studs on both the door and the window. And then we have the little broken studs here marked with a C. Those marks are done while the plates are together and then spread apart so that the actual material in between the studs and everything can be put in without being crooked. That way your wall gets to be squared and everything when you're done. These components on the outside here are the full-length king studs. King studs hold the whole component together. Inside the king studs, we have the jack studs. The jack studs are sometimes called tremors, depending on which part of the country you've learned to build with. And inside the window component, we have this top header, and we have the bottom window sill. The window sill is cut into the jack studs so that the actual jacks between the windows can be shimmed here and allow them to move a little bit. This header is normally not the right thickness unless it's made with an actual 4x material. If you don't have that on a job site, like we didn't have that with this particular model, we were able to shim it with a piece of plywood, which represents our half-inch plywood down here in real life. In this case, it's actually done with cardboard to make it to scale, but that helps make these headers the proper thickness for our wall. So that's another way it can be done. We did that here on both of these headers. The purpose of this header is to help absorb the load. So if you're going to take out a piece, like there's no stud right here, that downward vertical pressure from the roof, all the weight that's up here, has to be absorbed somewhere so that it's absorbed by putting this large beam in right here so that if you have glass or something else, you don't crush it. We can easily open and close the door, or we can easily have this window of glass in here because there's some large header or something above it dispersing the load to the side. So this load is transferred down to the jack stud. This load is transferred to this jack stud here on either side, so there's nothing bearing right here. As we move across this structure, anywhere you're going to have a small broken stud here, we typically call them cripples. the top area right here in the front. This is a gable style roof as opposed to like a shed roof or something that would be slanted to just one direction. This one's slanted in two directions, not three. It doesn't come down this way as well. It doesn't have a hip on it or anything like that. It's just a gable roof. So this gable style roof, this is called the gable end because you see the point right here, the end of this ridge beam, and it has several different components. These are the gable end studs. They're just small little nailer studs, and they allow us to put siding on this gable end. And there's little cuts or gaps inside this top piece here, which sits on top of a double top plate. There's actually on the top plate of the wall, there's a double top plate which wraps around and overlaps the two walls where they come together. And then there's a triple plate on here, the third plate, which is simply one of these ceiling joists. If you have drywall and you look up in a room, normally you're going to have a drywall or something up here. The end one is just rolled flat, or it's dropped flat so that there's a lip right here, and that lip allows you to also put drywall up here with the corner having something to nail into. You don't want that edge just kind of flapping around. So that edge, not only is it laid down flat, but it is notched where each of these little end studs go. These ceiling joists are also clipped. They're cut at an angle here so that when you put the roofing materials down here, the roofing material can sit flat on these rafters, which run the full length of the roof, without having the corner of this poking out, stopping the plywood from sitting down. That's why we clip these. The rafters are the top piece up here that hold up the actual roof structure. And these are typically made out of at least a 2x6, depending on the span or the length of them. Sometimes they're bigger. The end of them here, this is called the tail. The rafter tail on this particular example is plumb cut, meaning that it's perfectly vertical to the ground, and it is parallel to the rafter ridge right here. This is the ridge beam. The ridge beam is the top part of any roof. It runs across the top and connects together. You'll notice that these three pieces make a triangle. The ceiling joist, the rafter, and the ridge all together make a triangle, which is a very strong shape. That comes together to basically make, a truss. So trusses are typically what roofs are made with. There's one other little component in here that's kind of hard to see, but I can try and show it to you here in the video, and that's this little cutout right here. This cutout in the roof is called the bird's mouth, and the purpose for this bird's mouth is it stops the wall from, when the roof gets put pressure on it, it helps hold everything together, and it stops the walls from wanting to splay outward. The bird's mouth will actually catch the wall so that it can only come inward, and usually there's internal walls that stop it from doing that. So a whole bunch of different components. They all have their different purposes here, and a lot of different stuff you can learn from just this little model here. Anyway, if you guys have any other questions, that's the basic presentation that I'm looking for you guys. I want you to be able to demonstrate to me your knowledge of these different components we embedded in this little project, what their purpose is, why they're there, how you can utilize them. And I explained a little bit more than you would have to. I know we didn't go over every little aspect of that, but that just gives you an example of demonstrating your knowledge about these different things. So hopefully that helps you. Good luck with your presentations. Make sure that you're ready to do them, whether they're being done live on the day that we've decided is our final exam day, as a class, not necessarily as the school, but our class day for these presentations, or you're always welcome to make a video and present it to me ahead of time. If you're really nervous about talking in front of a crowd, you can do that. It just requires a little bit of extra work in editing. If you're in my honors or advanced classes, you not only have to do this with a video, but you will have to present the extra credit, which is also explaining to me the purpose of the sheathing and roofing water paper up top and your vapor barrier paper on the outside with the plywood. I want you guys to explain to me that plywood is going to wrap the entire structure. It's going to help with the shear strength so that the house doesn't want to rack under like an earthquake. We live in California. We're going to have strong earthquakes. We don't want the house falling over when it shakes. So plywood will help with that. And then on top of your plywood, we always have a waterproofing product, which is like this one here. It's called Tyvek. And Tyvek is vapor permeable. It allows the vapor to get out. It's got little perforations in it. It can be found in our priority mail envelopes. That's also made of Tyvek. And then the roof here is Also covered in plywood so that there's structure to put everything on. On top of that, there's going to be some sort of waterproofing. In this case, we have 30-pound felt paper. And then the shingle will go on top of that, which could be an asphalt shingle. It could be a tile of some sort, or clay tile, whatever the particular roofing is. So make sure if you're doing extra credit, you guys are presenting that, or if you're in the honors class, you're demonstrating that knowledge as well. All right, good luck. We'll see you guys later.